Hello students, continuing with the previous video, the next concept we have expectation, variance, covariance of joint probability distribution. So here are the definitions. If x is a discrete random variable taking the values x1, x2, so on xn, having the probability function f of x, then the first definition, that is the expectation we define. The expectation of x is denoted by e of x, and also it is denoted by mu x is defined by the relation e of x equal to summation I equal to 1 to n xi into f of xi, or simply summation x into f of x. So this expectation of x is, it is a sum of the product of random variable x and the corresponding probability. Okay, this is the expectation of x. Similarly, we can define expectation of y as summation j equal to 1 to n yj into g of yj, that is the product of the values, the sum of product of the values of y and its corresponding probabilities. This is expectation of y. Next, we define expectation of xy, which is given by summation I equal to 1 to n summation j equal to 1 to m xi into yj into jij. So this is the sum of the product of the variables x and y and also the corresponding joint probabilities in the table. Okay, this is the product, the value of x, the values of y, and this jij is the corresponding probability. Similarly, expectation of x square we define as summation I equal to 1 to n xi square into f of xi, or simply summation x square f of x. So it is a sum of x square into f of x. So f of x is what? It's a corresponding probability. Then expectation of y square is summation j equal to 1 to n yj into g of yj, or simply summation y square into g of y. The next definition is covariance of x and y, which is defined by the relation which is denoted as COV, that is we read as covariance of x and y. It is given as expectation of xy minus expectation of x into expectation of y. So these we defined in the previous. Substituting those values, we get the covariance of x and y. Then the definition variance or standard deviation. So it is defined as, that is a standard deviation of or variance of x. It is defined as expectation of x square minus expectation of x whole square. Then standard deviation of y or variance of y is expectation of y square minus expectation of y whole square. Next definition is correlation. Correlation of x and y we denote as rho of xy and is defined as covariance of xy. Covariance of xy we defined here. Okay, that value divided by sigma x into sigma y, that's the standard deviation of x into standard deviation of y. Okay, so these are the definitions. Now we take the problems finding all the expectations, variance, covariance and all. Okay, so here is the first problem. The joint probability distribution table for two random variables x and y is as follows. So the joint probability table is given here. So these are the values of x1 and 2, -2, -1, 4, 5 are the values of y, and the entries in the table are corresponding probabilities. Okay, the question is Determine the marginal probability distribution of x and y. So this kind of problems already we did in the previous video. And also compute expectation of x, y and xy and standard deviation of x and y, covariance of x and y, correlation of x and y. So finding correlation of x and y, it is nothing but we are finding all the values like expectation of x, y, xy, x square, y square, all the values we required to find the correlation. Okay. Further verify that x and y are dependent random variables and also find p of x plus y greater than 0. See, first we find the marginal distribution. So this is very simple. Again, you take the given joint probability table, take the sum zero point 0.1 plus 0.2 plus 0 plus 0.3, 0.6, 0.2 plus 0.1 plus 0.1 plus 0 is 0.4. Then we take the column wise 0.1 plus 0.2, 0.3, 0.2 plus 0.1 is 0.3, 0 plus 0.1 is 0.1, 0.3 plus 0 is 0.3. When you take the sum 0.6 plus 0.4 is 1, and when you take this sum 0.3 plus 0.3 plus 0.1 plus 0.3 is 1, we must get 1 here. Okay, so marginal distribution of x are 0.6 and 0.4, we write in this form. Then marginal distribution of y -2, -1, 4 and 5 are 0.3, 0.3, 0.1 and 0.3. Okay, next is expectation of x. So expectation of x is given by summation of x into f of x. Okay, we have the values of x, that is x1, x2, x1, x2, that is taking I equal to 1, x1, this becomes f of x1, taking I equal to 2, x2, f of x2. Okay, so we have two values of x, so these are the values of x and the corresponding probabilities. Now by referring the table, we substitute the values like x1 is 1, f of x1 is 0.6 plus x2 2 and f of x2 is 0.4. So likewise we substitute the values, then we get expectation of x. Okay, substituting the values we get the expectation of x. Similarly we can calculate expectation of y. Okay, we have four values of y, y1, y2, y3, y4, then g of y1, g of y2, g of y3 and g of y4. Substituting all the values we get expectation of y as 1. Then expectation of xy. Okay, so taking I equal to 1, j equal to 1, x1, y1, j11. So here we have to make the combinations. x1 taking I equal to 1, j equal to 2, x1, y2. The joint probability is j12. Taking again this x1 with the y3, x1, y3, j13. Again taking this x1 to the combination y4, x1, y4 into j14. Similarly we take the second x2 with y1, x2 with y2, x2 with y3, x2 with y4. Then all these value we take and take the corresponding joint probabilities. Then we substitute all the values, we get the answer 0.9. Then we find the variance, expectation of x square minus expectation of x whole square. This expectation of x value already we have, that is 1.4, right? Then this expectation of x square is given by summation of x square into f of x. So taking x as x1 and x as x2, f of x1 and f of x2, substituting the values we get the variance as 0.24, and sigma x is a standard deviation. Standard deviation is square root of 0.24. Square root of 0.24 is 0.49. Okay. In the same way we find the standard deviation of y. Then the covariance is given by expectation of xy minus expectation x into expectation of y, substituting all the values as we found these values in the previous steps. Then this is the answer. Then correlation is given by covariance of xy divided by sigma x into sigma y. Okay, all the values we found there. Then substituting the values, we get the answer minus 0.3. Now we have to verify that whether these are dependent or independent. So we take the product of these f of x1 into g of yj, that is jij. I take I equal to 1 and j equal to 1. So f of x1 from the table is 0.6, g of y1 from the table is 0.3, then j11 in the table is 0.1. When we take the product of these, we get 0.18, so it is not equal to 0.1. Okay, so therefore when this condition is not satisfying, x and y are dependent random variable. So this is the one kind of problem. Similarly, we can try the similar type of problem. Now the next type of the problem, see here, the joint probability distribution of two discrete random variables x and y is given by f of xy equal to k into 2x plus y, where x and y are integers such that x value lies between 0 and 2, y value lies between 0 and 3. Okay, so here in this problem, the joint probability table is not given. So in the previous problem, the joint probability table was given, but in this problem, instead of the joint probability table, the function is given and the values of x and y are given. With the help of these values of x and y, and using this given function, we have to form the table. After forming the table, we have to find the value of constant k. Next question, marginal distribution of x and y. Then we have to show that x and y are dependent. Okay. Now we take the values of x. It is given from 0 to 2, that we divide as 0, 1, 2. This interval we take as a 0, 1, 2, that is from 0 to 2. Then y value from 0 to 3, with those we take as 0, 1, 2, 3. Okay, and the function is k into 2x plus y. Now what we do, we take the table. So here the values of x are 0, 1, 2. The values of y are 0, 1, 2, 3. Okay, now we take the values of x and y as, take the first combination, x equal to 0 and y equal to 0 here. This entry is 0. Then you take the combination x equal to 0 and y equal to 1. It is k. Then you take x equal to 0 and y equal to 2. We get a 2k here in the function. Then you take x equal to 0 and y equal to 3. We get 3k. Next, we take x equal to 1 and y equal to 0. We get a 2k. X equal to 1 and y equal to 1 in the function. We get 3k. X equal to 1 and y equal to 2. We get 4k. X equal to 1 and y equal to 3 here, we get 5k. Similarly, this combination 2 0 2 1 2 2 and 2 3 we have to make, and we get the values of the joint probabilities. Now we take the marginal distribution of x and the marginal distribution of y. Okay, with the help of these marginal distributions, we can find the first, that is k. Now taking the sum, 0 plus k plus 2k plus 3k, 6k. Likewise, we have to take the sum and also column wise sum. Okay, so these are the marginal distribution of x and these are the marginal distribution of y. And now we take the sum, 6k plus 14k plus 22k is 42k. Then this sum, 6k plus 9k plus 12k plus 15k, it is 42. This sum and this sum must be same, and already we know this 42k, this the sum of each entries in the table must be 1, means this 42k is 1. From this we get the value of k as 1 by 42. So this solution is not continued. So here what you need to do, again you take the table taking the values of x and y, and now you substitute the value of k. Wherever k is there, everywhere you put k equal to 1 by 42. After substitution of k value, take the second question, marginal distribution of x and y, that is 6 by 42, 14 by 42, 22 by 42. So these are the marginal distribution of x. Similarly here you substitute 6 by 42, 9 by 42, 12 by 42, 15 by 42. These are the marginal distribution of y. And also you can verify, you have to show that these x and y are dependent. So this is very simple. When you take this 6 f of x1 and this I take g of y1, okay, equal to this is j11. What is f of x1? 6 by 42. 6 by 42 is 1 by 7 into, then g of y1, again this is 6 by 42, that is 1 by 7. So j11, the corresponding entry is here 0. Okay, then 1 by 7 into 1 by 7, 1 by 49. So this is not equal to 0, hence x and y are dependent. Okay, so this is a one type of problem. The next, another type of the problem is, see, a fair coin is tossed thrice. The random variables x and y are defined as follows. So even in this problem also the joint probability is not given. Depending on the given data you have to form the table. See, what are the conditions given? The value of x, the x value takes as 0 when head occurs on the first toss, and the value of x takes as 1 when tail occurs on the first toss. This is a one condition, and y values is what? It's the number of heads. The questions are, determine the joint probability distribution of x and y. Means with the help of this given data you have to form the joint probability distribution table. Then you have to find out expectation of x, y, xy, and standard deviation of x and y, and also we have to compute covariance and correlation. Now the interesting part is forming the joint probability table, that is the sample space, means the collection of all the output. Okay, it's a sample space, and the association random variables x and y is given by the following table. See, the sample space is what? It is all outputs. The given is when a fair coin is tossed thrice, means when we toss a fair coin 3 times we get all the 3 times head. That's how, this is the one possibility, h all heads. Again the other possibilities are, we may get 2 heads and 1 tail, head tail head, tail head head, head tail tail, tail head tail, tail tail head, and tail tail tail. These are all the 8 possibilities when we toss the fair coin. These are all the 8 possibilities. Now we write the values of x and y. See, the value of x is 0 when head comes first. In the toss, in all these possibilities, if the first we have a head, means we take x equal to 0. So in this possibility head is the first one, 0. Here also head we have a first, so we take 0. So in this, the first is tail. When the first one is tail, we take x value as 1. So here head 0, here tail, so we take x as 1, here tail 1, here tail 1. Now the value of y, how we take? It's the number of heads. How many heads we have? 3. So we have value of y is 3. Here two values of two heads are there. So y is 2. Here also two heads 2. Two heads, value of y is 2. One head is here. So taking y equal to 1. Here also 1. Here also 1. And there is no heads means 0. So we got the values of x and y, that we take as x as 0 and 1. We have repeated 0 and repeated 1. We take those as a 0 and 1. And similarly y values are 0, 1, 2, 3. This is the way we take the values of x and y, and then we form the table taking 0, 1, 0, 1, 2, 3. Then how we consider the probabilities, right? So here totally there are 8 outcomes, that is n equal to 8. Okay, and this m is the number of favorable cases. Okay, and then probability is given by m divided by n. This is the formula. Now what m takes? See, we take the combination of first 0, 0. From this table 0, 0, x0 and y0, is there any that kind of combination? No. There is no combination like 0, 0 in the table. Therefore, the probability is 0. Then we take 0 and 1. 0 and 1 here. 0 and 1. There is a 1 combination, not 1, 0. It is a 0, 1. When you take 0, 1, so here total n is 8, and there is a favorable case. Favorable case means for which we are finding the probability for this combination m equal to 1, then 1 by 8. This is the way we write the table. Then the combination of 0, 2. 0, 2 we have 2 times. So m equal to 2. 2 divided by 8, that is 1 by 4. Then 0, 3. 0, 3 we have only 1. 1 by 8. Then 1, 0. Only one combination. 1 by 8. Okay. So 1, 1. 2 times. 2 by 8 is 1 by 4. Then 1, 2. Only 1 times. 1 by 8. Then 1, 3. We don't have any 1, 3 combination. So probability is 0. Then so we have all the probabilities now. Now the question is what? First it is over. That is we form joint probability table. Now we have to find out marginal distributions. That is taking the sum. These are the probability marginal distribution of x, and taking these sum. So these are the probabilities of marginal distribution of y. Okay, with the help of this joint probability table, we find expectation of x, y, xy, x square, y square. Okay, all the probabilities, and we find, and also these required covariance and correlation. So finding these values already we discussed in the previous problem. So that calculations you please try. Okay, so these are the problems on the expectations, variance, covariance and correlation. Okay, thank you.